In this video, I will go over the homework that follows the lecture on Introduction to Sequences. And as always, I hope that you watched the video lecture. And let's go ahead and get started. And here's the first problem. And in this question, we are asked to write the first few terms of a given sequence, and the sequence is presented to us by this formula. Notice that that extra negative can be combined, or rather, there's a couple things I'm going to do here. I'm going to separate -8, which is a common technique, into negative sign and the actual numerical part of it, and then we're going to take this extra negative and add it to the negative part. So these two definitions are equivalent. And now we're going to produce a1 by replacing n with 1. And the answer is 8/3. Now we're going to produce a2 by replacing n with 2. And the answer is -64/3, and so on. Note that the negative just means that the sign is changing every other term. So what's 8^3? And 12. And 8 to the power 4 is 4096. Now that I have Desmos opened anyway, I can show you how to use it to your advantage. So for example, if this is your n, here you can easily write all the elements of your sequence by typing up the formula. And we have 8 to the power n divided by 3. And when n equals 1, we get 8/3, 2, 3, 4, and so on. Now, for some reason it doesn't type it as a fraction, so I guess our way is better for the sake of answering this question. But in terms of functionality, you know, sometimes we don't have time to do all these computations, then we can delegate this task to technology one way or another. All right, so next problem. We are given a sequence by recursive formula, and there are two steps to this problem. First, we need to figure out what that sequence is, and then we're going to try to produce the general formula. There is no easy way to figure out the general formula from the recursive formula. So the first term is 3, then it's twice as much, so it's going to be 6, then it's going to be twice as much, then it's going to be 12, then it's going to be twice as much, 24, and so on. And now in order for us to find the general formula, we may have to play with this sequence, and what I would suggest is to factor out 3 from every term, and then we'll be able to see the pattern. We have 3 times 2, so if we write 3 times 2 here, it's going to be 3 times 2 to the power 0, 3 times 2 to the power 1, 3 times 2 to the power 2, 3 times 2 to the power 3, and so on. So this seems to be the pattern, and we're going to summarize this pattern by writing it like this. So we have 2 to the power n, and we allow n to be 0, 1, 2, 3, and so on. So that seems to be the working formula. And let's see. And Newton agrees with us. We have another similar problem. The sequence is given to us recursively, and the rule is somewhat clear. This is the reciprocal, so pretty much we're going to take the reciprocal of the nth term multiplied by -1/2, and then add 1 to it. So if a0 is -2, then a1 will be -1 2 times, and here I put the previous term, so it's 1/4 plus 1, so it's 5/4. Now a2 will be the reciprocal of this. 5/2. Reciprocal of that is 2/5. So it's -2/5 plus 1, so it's 3/5. A3 is -1 over 2 times 3/5 plus 1. So we have 6/5, 5/6, so it's 5/6. 1 minus 5/6 is just 1/6. A4 is -1 over 2 times 1/6. -3 plus 1, and we're back to -2. That's an interesting fact. So it's just like a looping sequence. But anyway, before I enter it, it doesn't hurt to check my work. That just look a little scary like this. So we're gonna type. So what we can do here is we can type the recursive formula here. So if this is my nth term, then the next one will be -1/2 a sub n, the reciprocal of it, so it's here, plus 1, and if nth term is -2, then we have 1.25. So if this term is 1.25, so we kind of have to manually run this to see what happens. I think we pretty much... Did we list all 4 elements? Let's see. So A1 is 5/4, A2 is 3/5, A3 is 1/6. That's the part that I miss. This is 0.6. This is 1/6. and now we put 1/6 in here, we're back to -2, right, there you go. So now it looks consistent. So again, we're just learning to work with definition of sequences, whether it's recursive or pattern or general formula. To us it shouldn't matter. This is what, number 4? We have somewhat large numbers here. But among these large numbers, we do see a hint. So the hint is we divide something by 25. So when n equals 1, when n equals 2, when n equals 3, when n equals 4, when n equals 5. So here we see 5 squared, and it could be part of the pattern, right? So the pattern could be we're dividing by n squared, right? So this is our guess. Now, to see what's going on in the numerator, we probably need to factor out the 1296. We need to do some math here. 1, 6, 7, 6. I'm just gonna see if there's like some pattern. Right, so it looks like we went from here to here. The numerator become 96 times larger. So 7496 divided by 5184. Also, what's 1296? It's 36 squared. So the first one is, not sure if it means anything, but it's 36 squared. Second one is times and a half bigger, so we multiplied by 3, so it's but remember, that's part of the pattern, right? So we're trying to figure out if this is 36 squared over 1 squared, then the next one is, it's going to be something over 2 squared. So let's multiply 19 over 4 by 4. So it is, does it look like it's 36 cubed divided by 2 squared? Let's check that. 36 cubed divided by 2 squared. No, where did I get that from? It's times and a half, so it's times 3 over 2. Is that right? So 1296 times 3 over 2. That's what we get, right? So we get 2 to the power. So we get, it's 36 squared times 6 over 2 squared. That should be right. 36 squared times 6. So now if I'm trying to predict this pattern, it's going to be, what does it look like? Well, here we're going to have 3 squared, for example. So let's take 5184 multiplied by 3 squared, and let's divide all that by the previous term, or let's say 36 squared. So we get 36 squared times 6 squared. Is that the pattern? So if I had to guess, this one will be 36 squared times, I would say 6 cubed divided by 4 squared. Let's try. 36. Actually, you know what we can do here? We can actually type this table, type this formula. The formula that we think is going to work is 36 to the power 2 times 6 to the power, it's going to be n minus 1, and then we divide by n squared. Let's see if that works. So n is equal to 1. We get 1296, 3, 4, 5. Let's just check. 167, 9616 divided by 25. Yeah, there you go. So that seems to be the formula. So it is 36 to the power 2. That's just not going anywhere. And we have 6 to the power n minus 1. That's the answer. And we got it. Actually, reading this solution can help us understand what's in Newton's mind when they asking us this type of questions. Alright, so we have another recursive sequence. The rule is simple. We take the given element and multiply it by negative 2/3. And let's enter the answer. And we have another similar problem. Again, we're just learning the basics of working with sequences. So here we have 7 times 9 is 63, negative 63 minus 9 is negative, what, 72? 72 divided by 8, that's negative 9. 83 is 7 times negative 9 minus 9 eighths, negative 63. I guess because we're doing common denominator anyway, so might as well keep it as 8. So we have negative 400, negative 504, negative 513 over 8. A4 will be 7 times that. So we have negative, and it's going to be 7 times 513. It's 3500. 7 times 13, it's 91. So 3591 plus 9, 3600. That seems to be as if it can be simplified, so it's negative 400. Again, we can check our work by typing a sub n here. And here we type recursive formula. So the way we use Desmos for recursive formulas is not exactly the same way that we use Desmos for general formula. Keep that in mind. We have to kind of manually re-enter all the terms. So negative 9 over 8. So far it seems like it's good. This is negative 513 over 8. Yep. And we got negative 450. Well, I'm glad I'm checking this because 3600 divided by 8 is certainly not 400. Need to check my arithmetic skills. This is the right answer. And that's it. Ready to enter. A1 is negative 9 over 8. A2 is negative 9. A3 is negative 513 over 8. And then we got negative 450. Alright, we have a general formula. So when n is equal to 1, we simply plug in 1 when n equals 2, we plug in 2. When n equals 3, we plug in 3. When n equals 4, we plug in 4. And that should be it. Next problem. Another general formula. So when n equals 1, I guess we'll do I'm curious what will happen. I guess it's not too bad. Well, some of them are easy, right? So, for example, well, still, this is same as 7 halves minus 19 thirds. This is same as 7 minus 19 thirds. This is 21 fourths minus 19 thirds. This is 7 fourths minus 19 thirds. What if I don't even try to simplify it? What will happen? Good enough. Another one of those recognizing the pattern problems. So we have 10, negative 50, 1000 over 3. Again, that could give away the pattern. Five zeros here over 3. So now the fact that we have 3 in the third and sixth elements could mean that either we always have 3, or it could be that this 3 is actually 6 and we actually have twice as much over here, like this. So that's what that can be. Now we also notice that the plus minus changes, so we have plus minus, plus minus, plus minus. That's something we can easily create the pattern for. We have negative 1 to the power. Now for n equals 1 is positive, so when n is even, this will be positive, so we want it to be even when n is odd, so we just add 1 over here. And now we have, in the denominator, it looks like we can start with n. It also looks like we have like, we're gonna have to play with this pattern, right? We have a lot of zeros there, so that means there's a lot of multiplication by 10. So first let's write the denominators. We have 10 over 1 minus 100 over 2, 1000 over 3, negative, and now here we have to put 4 over here, but what do we have here? 10,000. Here we have 5, but then it's going to be 100,000, and I think that's the pattern, right? So I think we got it. So that's the number of zeros right there. So we have 10 to the power n over n, and then we have a alternating sign. Negative 1 to the power n minus 1, 10 to the power n divided by n. Alright, so here we have another formula, but it's a multiple choice question. But I'm going to try not to look at the options and try to identify the pattern using the techniques that we learned, kind of went over earlier. Again, looking at the denominator, it looks like that's clearly part of the pattern. So dividing by n, that's part of the pattern. Then we also have signs changing like this, so it's going to be negative 1 to the power n. It's positive when n is even. And 5 to the power n seems like to be also the pattern. So we have negative 5 over 1, 5 squared over 2, negative 5 cubed over 3, and so on. So this should be the answer. Now checking which one of them matches this pattern, and it's this one. Alright, another similar question. We have 16, 4, 64 over 27, 2, 256 over 125, 64 over 27. Looks like we have a lot of powers. N equals 1, n equals 2, n equals 3, n equals 4, n equals 5, n equals 6. Now we have, here's the pattern. We have 3 cube here. We have 5 cube here. So I would assume we should have 6 cube here. But 27 is only 3 cubes, so we need to multiply it by another 8. So now we have 6 cube, but what we have in the numerator? So we just have to put 4 cube here. 4 cube is 64, so we have to put 2 times 64 is 128. So it seems like the pattern is now pretty clear. So we have 512 here. So this will be probably 2 cube 32. This will be 1 cube 16. And we have so 16 is 2 to the power 4. 32 is 2 to the power 5. 64 is 2 to the power 6. And so on. So the pattern is we have n cube, and we have 2 to the power, looks like it's n plus 3. So the answer is and it seems like we completed this homework. If you have any questions, please feel free to reach out.